Hey guys, my name is Diego Castillo, and I'm here today to talk to you about one way that mechanical engineering has affected or plays a role in the exploration and development of the Arctic. One way mechanical engineering comes into play is through dynamic positioning, which is a computer-operated system which allows an offshore vessel to stay in place or heading by using the vessel's propellers and thrusters. Dynamic positioning is especially needed in the Arctic because ice is a lot harder to counteract than water, and therefore it makes it a lot harder for vessels to position themselves where they need to be and stay in that position. Operating these vessels in heavy or even light ice conditions is a lot different than operating vessels in open water. Large vessels like drilling rigs that are designed to operate in open water only need to take into consideration different conditions and waves created by these conditions, whereas in the Arctic, drifting icebergs and ice fields create a physical barrier that need to be broken or avoided altogether. Essentially, the dynamic positioning system receives information from the different sensors measuring things such as the speed, the direction of the wind, the vessel's position, the motion, and the gyro compasses. This then allows the computer program to adjust the steering angle and the thruster output needed in order to get the vessel to move in the desired direction. Now, some of you may be wondering the significance of dynamic positioning or why it is important. Normally, out in open water, as soon as the thrusters stop, so does the vessel. But in the Arctic, the ice fields are constantly changing directions and will drag the vessel along if the proper precautions are not taken, such as ensuring there is a patch of broken ice around it so that it is free to rotate if need be. If a vessel gets dragged along, the force required by the thrusters to break through the ice is very high, and so the energy that is used would otherwise be unnecessary to use. This wastes time and fuel, and therefore money. This is especially crucial for vessels such as drilling rigs because it slows or stops production, and the forces acting on it increase the risk of error. But with the dynamic positioning systems, these risks are greatly lowered since it allows the vessel to adapt to its surroundings. This in turn results in easier access to resources. Although this technology has greatly affected and enhanced our capabilities in the Arctic, it is not perfect and can run into some problems. Since it is a complex system and there needs to be someone running it, there is a combination of possible mechanical and human error. The system is also not cheap to install and requires a lot of fuel, so essentially the system itself is an investment. Among these, there are also hazards from the thrusters and propellers, and a higher maintenance of the mechanical system is needed. Since the dynamic positioning system is a relatively recent technological advance, we are still not very familiar or experienced in dealing with them in the Arctic. Although we are advancing more each day and mechanical engineering will continue to play a large role in the exploration and development of the Arctic, dynamic positioning systems, along with other mechanical engineering developments such as ice-breaking vessels, harvesting of natural energy, and drilling systems, have allowed us to expand our capabilities and access resources that were previously unreachable. Even with these advances in technology and with the techniques being used to overcome the adversities with which we are faced, dealing with the Arctic ice is still difficult and requires a lot of planning ahead and coordination. The dynamic positioning system simply allows for the vessels to move in a certain direction in a smaller time interval, or to remain in a desired position so as to carry out its purpose. This means that in turn, the process such as drilling are made easier and done more efficiently, and therefore costs go down. And it also allows for a better understanding of how processes should be adjusted according to the conditions of its surroundings. This has proved so effective that other types of ships and vessels have adopted the dynamic positioning system, which shows it has impacted us not only in the Arctic but all around the world. Thank you for listening.